Now in this session we have seen all the module 2 elastic properties of material, and now we are going to start with assignment activity, and also we see the concept beyond the syllabus which deals with the beams and the bridges. Now we look at the assignment, a small quiz like thing. We'll see the choose the multiple question answer. Now the quiz is, which of the following is not elastic? Option A quartz, option B steel, option C rubber, and D putty. So the question is which of the following is not elastic? So here the answer will be putty. Putty is not elastic. Next, go with the next question. Annealing is a process of heating and then option A cooling slowly, option B rapid cooling, option C both A and B, and D none. So annealing is a process of heating and then cooling slowly. So option A is the right answer. Next is strain hardening is a process of making metal soft by adding impurities, making metal harder by plastic deformation, heat treatment to decrease the yield point. So the answer is making the metal harder by plastic deformation. So option B is correct. Next is a Poisson's ratio. Poisson's ratio is lateral strain by longitudinal strain. B beta by alpha. And option C both A and B. And D is longitudinal strain by lateral strain. Here Poisson's ratio is lateral strain by longitudinal strain, and also the formula is beta by alpha. So both A and B is the right answer. So option C both A and B is the answer for the Poisson's ratio. Next, relation between Young's modulus and longitudinal strain coefficient Y is 1 by beta. Is it true or false? The relation between Young's modulus and longitudinal strain coefficient. Remember here longitudinal strain coefficient is nothing but alpha, but here Y is given as 1 by beta. So this statement is false. So for fifth multiple choice question, B is the answer. It is a false. It is Y is equal to 1 by alpha. Next, sixth, expression for K in terms of alpha and beta. So K is equal to 1 by 3 into alpha plus 2 beta, and B is K is equal to 1 by 3 into alpha minus 2 beta. C is K is equal to 1 by 2 into alpha plus beta, and D is equal to K is 1 by 2 into alpha minus beta. If you look at the expressions carefully, option B will be the correct answer, where bulk modulus is given by 1 by 3 into alpha minus 2 beta. If you look at the equation, if you do the derivations, then you will be able to analyze this. Okay, next, limiting values of sigma, that is Poisson's ratio, minus 1 to 0.5. Yes, sigma lies between minus 1 to 0.5. So this statement is true. Option A is correct. Next, the layer of uniform beam which do not undergo any change in its dimension when the beam is subjected to bending within the elastic limit. So it is a layer of uniform beam which do not undergo any change in its dimension when the beam is subjected to bending within the elastic limit. Option A is neutral surface, B is neutral axis, C is option A and B, and D is none. Here the question is given as a layer. Layer means it is a surface. So option A is the neutral surface, the layer of uniform beam. If it is an axis, then it becomes a option B. So it is a neutral surface. Option A is correct answer. Next, 9. Beams are used in fabrication of trolley waves, in the elevators, in the construction of platforms and bridges, and D is all the above. Usually beams are used in all the above. This means fabrication of trolley ways, in the elevators, in the construction of platforms and bridges, and all the above. So the option for 9 is D, all the above. Next, a rigid body is suspended by a wire clamped to a support and body executed to and fro turning motion with wire as its axis is called? Simple pendulum, torsional pendulum, rigid pendulum, none of the above. So what exactly here? Simple pendulum is making to and fro motion which is along horizontal direction, but here a rigid body is suspended by a wire clamped to a support and body executes to and fro turning motion. That means a twist with a wire as its axis is called as option B, torsional pendulum. This is a torsion of a cylinder we have seen, and torsional pendulum we will be doing in the physics lab experiment. So it is a torsional pendulum because it is a turning motion with the wire as its axis. It is a twist. So for 10, option B is the correct answer. Next, rigidity modulus can be determined using a torsional pendulum. True or false? Yes, rigidity modulus can be determined using a torsional pendulum. So for 11, option A is the correct answer. Here some of the numericals I have given here. You please go through and try to get the answers. Values are also, answers also given. Now we will see something beyond the content, beyond the syllabus. Or if you want me to do these problems, we will do in the class. This is a small exercise. It's like an assignment. You can solve it and get the answers. Now we will see some content beyond the syllabus. Where are the different types of beams? We have seen only 4 types of beams. Beyond that 4 times, there are many more 4 types of beams. Here I have given a small figures where you can see the different types of beams, and this is a content beyond the syllabus. Just for your interest, I have given this. Reinforced concrete beam. As shown in the figure here, you can see the reinforced concrete beam. This is a reinforced concrete beam. That means with the iron and cement RCC, we will be using this reinforced concrete beam where you can see in the construction of the buildings or also in the bridges. Next is the steel beams. Here, this is a beam. It is like a steel one where you can see in the railway tracks. It is a steel beam. Railway tracks are having this type of beam, this type of steel things where track is being used here. This is called as an I-beam, or this is a steel one made of steel. For tracks it will be used. Next is timber beam. Here timber beam is with the timber we can make these beams to have a support. These are few more additional things where you can find in the different types of beams. Next here, as I told you here, it is an I-beam. Here this is an I-beam where it is used in a railway tracks. Here beam I section is preferred to rectangular section for resisting the bending moment. Usually bending moment happens when there is a bend, when the clamp is fixed at 2 ends and in the weight is increased, there will be a bend as you have seen in the bending moment of a beam. To avoid such type of bendings, this is I-beams are used. Why this I-beams is the shape is like a I here. The shape is like a I here, this one. And this is called as a web, and these flat surfaces are called as flange, and this part, the one which connects two flat surfaces is a web. It is called as a web. Here beams, I section beams are preferred to rectangular section for resisting the bending moment. We have seen in the bending moment there is a bend where the neutral axis is made fixed. But this I-beams resist the bending moment. We'll see. In I section, more than 80% of the bending moment is resisted by the flanges itself. That means most of the bends are being taken by the flanges itself. I section has higher moment of resistance because the areas of flanges is always is away from the neutral axis. That is to avoid the bending moment. This I section flanges will withhold most of the things, and the flanges are supported by the web, so bending moment will be decreased. In a beam of I section, more materials is positioned near the outer fibers. In the I section filter, the more material is positioned near the outer fibers, representing the regions of greater stress. This will be of greater stress. This part will be having a greater stress, representing the, and hence is stronger than the beam of rectangular cross section. So these are the, here I-beams are used. If you see the railway track, even the railway track has this type of a thing. If you closely observe, the railway track will be having the I steel beam. Okay, next is bridges. There are 4 types of bridges. beam bridges, arc bridges, cantilever bridges and suspension bridges. You can see over here the beam bridge. Here this is a beam bridge supported by two fixed one. This is a beam bridge. This is an arc bridge and this is a suspension bridge and this is a cantilever bridge. So there are many types of bridges and these are the four basic types of bridges: beam bridge, arc bridge, cantilever bridge and suspension bridges. Next you can see the olden style of bridges where they are old. British people, they used to construct bridges in this way. Old style bridges, you can see this is the one where you see usually when there is a water and if you want to move from one side to another, this wooden bridges made of wood. And next this is previous old constructions where British people were there when at that time. This is the way. And this is a steel bridge where the railing is been done with the steel and in between the two tunnels there is a bridge connected here. These are old style of bridges. Here new bridges with new technology and the designs. You can see here suspension bridge, strings, arc type bridges. Here it is of strings. This is the latest technology between the two hills. These are few new bridges which are constructed with a better technology. Thank you.